topics today include reviewing the benefits and features of OrCAD Library Builder, and through the use of slides and then walking through the tutorial, we'll navigate the OrCAD Library Builder's user interface, including the new Schematic Symbol Creation Assistant. The main focus of the webinar is going to be the Schematic Symbol tool, where we'll discuss, as I had mentioned, the benefits and features, reviewing the user interface, and the extraction of various PDF datasheet styles. I'll discuss how we can validate extracted content to ensure error-free capture symbol creation, and then I'll demonstrate the ease of creating PCB footprints from templates and also generate accompanying step models, followed by verification of the symbol and the footprint to make sure that they're in sync. I have about 10 slides reviewing these topics, and then I'll switch to the OrCAD Library Builder for the tutorial. The following bullets kind of summarize the benefits of OrCAD Library Builder, and one of the most apparent benefits is the single environment to build logical symbols and footprints. Most CAD systems have totally unique tools, one for building symbols and another one for building footprints, without direct interaction between the two. Eliminate countless hours of manual entry to create first-time correct symbols and footprints. Almost all devices have a vendor data sheet. However, if you're only visually referencing that data sheet to then manually type in pin text that could be up to 100 characters long, and with thousands of pins on a device, you're not being very efficient. Having been a designer for many years myself, one of the most difficult items in building a surface mount footprint is determining the correct pad size, the toe, heel, and side adjustments to match the physical pin on the package that will meet your manufacturing processes. With OrCAD Library Builder, we have powerful algorithms that automatically calculate the pads per IPC 7351 specification. Validating syntax rules to build correct capture symbols and making sure that the symbol and the footprint are in sync is an added benefit. Another benefit is the ability to customize and save your own corporate drafting standards, and the ability to save unique footprints as your own templates. And probably most certainly a management objective is the benefit in time savings associated with OrCAD Library Builder, with a quick return on your company's investment. Some specific features of OrCAD Library Builder are the abilities to extract pin tables, as shown in this slide, or pin tables spanning multiple pages. We can extract pin names and pin numbers from graphical diagrams, as shown here, or from BGA maps, just to name a few. Another example of a PDF table. For those new and occasional users of OrCAD Library Builder, there's a symbol creation assistant that will dynamically guide users through the symbol creation process. The assistant can be activated when starting a new symbol, or by simply pulling down the help command and clicking on the symbol library assistant. Prior to committing PDF data, users can preview the selected data from the datasheet and verify it dynamically. As things change in your selection window, the contents will be updated in this preview window. The extracted data is then optimized into a final spreadsheet of information that contains the data that will be populated onto the logic symbol graphics. And then if you select File Export, it will automatically create the OrCAD Capture library symbol for you. And using the Windows Cascade feature, multiple views can be displayed. Again, we're talking about one GUI to build symbols and footprints and also to view the extracted content as well as the PDF data sheet. And it makes traversing any of the windows and cross-referencing one to the other very easy. Another important feature is the validating the data extracted from the PDF will be accurate when it is exported into OrCAD Capture. So there are powerful algorithms that will ensure matching of capture rules like pin names, pin types, and rectifying duplicate pin numbers. With the click of a button, symbols can be created automatically from the table by using placement rules, or interactively by selecting data in the table and placing pins using the position icons of, for example, left, right, top, bottom. That would be this icon set across the top here, or drag and drop. So in this example, selecting the data bus and then clicking icon to place the pins on the left, it will position all those pins on the left side. If you're creating footprints, by selecting the footprint application, which again is just a menu pull down, or it could be clicking the icon for the footprint. This one is for the symbol, this one's for the footprint, viewing the PDF obviously, and then the scratch pad of data that's in a tabular form. So by clicking the footprint, one can choose the particular IPC calculator. We also call them templates, but probably most people call them templates, but an IPC calculator is termed because it actually has mathematical equations behind that particular template that by changing the package size, it will automatically adjust the pads for the PCB environment. So it'll calculate those as well as it'll create step models based on that data. So OrCAD Library Builder ships with 100% of the SMD packages that are defined in the IPC 7351 spec, plus through-hole devices and connector templates. And users can also create footprints per vendor recommended land patterns. So not only is it an IPC calculator, but if you need to customize that part per a recommended land pattern from the vendor, you can customize that part as well. So entering dimensions from the data sheets into the available fields, that would be these fields over here, or by just clicking on the dimension and using the dynamic associative editor, OrCAD Library Builder will then use those mathematical equations to calculate the required package and pad stack sizes. Clicking on reports, you can quickly verify whether or not the symbol and the footprint pin counts match. And clicking generate step will automatically build the 3D step model. The variant editor also allows you to customize for things like pin counts, pin configuration, pad sizes that you might have to create. Again, that would be more from a recommended vendor land pattern. And then you can save those customized templates. Here's just another example of customizing pad stacks for a particular USB style connector, let's say. The system requirements for OrCAD Library Builder, we do support Windows, Microsoft Windows 7, 8, and Vista. We do not support XP due to the fact that XP doesn't support one of the other requirements, which is .NET. And .NET is just an application framework that provides services such as security, memory management, and exception handling. OrCAD Library Builder does require Cadence 16.6 or 17.2, the new release. And its licensing is managed by the Cadence license manager that's already installed on your machine from the previous Cadence SPB or OrCAD products installation. And in order to run OrCAD Library Builder, you must have a valid license that's issued by Cadence. And to create footprints, a license for the PCB editor is also required. So let's move over to an actual tutorial walkthrough. And I call it a tutorial walkthrough because in this example, if you open up help from your tool, there's a tutorial in here, and that's the tutorial that we'll be walking through in the first example. So by just selecting different tabs within here, within the tutorial help, it's a guided step-by-step process of doing actually what we're going to do in the training class today. So for those of you that have received OrCAD Library Builder as part of the OrCAD Capture free promotion, you'll have OrCAD Library Builder in addition to several other tools. And for those of you that may already have purchased OrCAD Library Builder, you can also use this tutorial. There's a couple different samples here that you can follow step by step. So this is the main canvas for the symbols and the footprints. If I click on the symbol tool, here's the canvas for creating symbols, footprint tool for opening up a template for your particular footprint style that you need to create, and then the PDF after you've opened the PDF would be visible here. It's typical Windows menu pull downs with a set of icons that will match the tool set that you're working in. And as I had mentioned, there is under help, a symbol creation assistant that you can invoke, and I'll do that once I open up a PDF here. Well, I can do it now. So typically I use this in a dual environment, so it's on my other screen, so I'll just slide it over here. But this will give you a step-by-step guide as to what the steps are necessary to create a logic symbol. So by reading the information over in the right panel and clicking go, it'll take you to that step in the process of building the logical symbol. Also, let's talk a little bit about libraries, since this is kind of a tutorial walkthrough and training class, not just a demo necessarily. So under settings is where you would configure your libraries. Remember that OrCAD Library Builder is an application that's kind of pinned onto OrCAD Capture and OrCAD or Allegro PCB editor. So when you create a part in this environment, you're actually saving it to a file format that is this environment. It's an XML file. There's unique XML files for the symbol, which is an eSym extension, and then there's one for footprints that's unique. It's called EFPT, I believe, for the footprint extension. That means that since they're resident only for this tool, you can save your logic symbols and your footprints to the same project. You don't have to do any library mapping to put your ICs in one folder, your power devices in another folder, or your footprints in yet a different folder. Just my suggestion is just use one project folder, and to set up a folder, let's say if we wanted to add a new folder here, I'll just click on Browse out to my computer, and I'll just go down and I'll select a project folder that I want to store these in called Library. I now have two folders here, but I'm going to be using, let's say, Library. Currently, my Library folder is empty. So I'm in Library right here. There isn't any files in there. And as we progress, I'll call it up to show you what gets populated in that folder as we go. And then there's some other settings here for what your default template is. We'll talk about templates in a little bit when we create the graphics. The export directory where you actually want to write the .olb file to. And then there's some setups for the footprint tool to release to a library. Remember that here we are building a part in a local file format, and then to get it into OrCAD Capture and to Allegro requires a file export menu pull down command. So you would export it, and it's going to write the logic symbol or the footprint to those appropriate tools in those two tool formats. And then the release to library on the Allegro side lets you move from the local project directory by clicking a release to library, and it'll move your draw file, your PSM, and your pad stacks and your shapes to a pre-release folder that you would use for your process of approving parts, or if you wanted to any directory. All right, so let's begin by just doing a file, new, symbol from a PDF. Now we also can create symbols from text files, from things like comma-separated files, tab-separated, etc. And you can also create a symbol from a FPGA compiler report. In this case, we're just going to open up a PDF. So I'm going to say, I can give it a part name here. I'll show you that we could change that part name. We could type it in now if I wanted to, or I could copy it from some other place and paste it in here. I'll show you how we can do that from the tool. And the library that I might want to put that part that I'm building into. And then I'm going to browse out to select a PDF. Actually, well, okay, we can do it that way. So I'm going to open that PDF. So here's the PDF. If I went back over to my, let's see if I still have it up here. If I went back over to my symbol assistant, it says selected area. So I already have the PDF open. If I had not, and I had clicked on that and said go, it would have launched the Explorer to find the PDF file that I want to open. And so by reading the commentation, or the documentation on the right, the commentary, locate the page in the PDF that you want to extract information from. So what I can do is I can get back over here and I would browse for the information that I'm going to extract. And remember from the slide presentation, we could extract things like tables, we could extract graphical views like this. Whenever you have the option to do a table, that's my suggestion, because there's more information in the table than there is in one of these graphical views or a bitmap of a BGA. So when you can use tables, do that. And going back over here, if I click the Go button, it's going to then ask me to select the area. So I'm going to say, okay, I'm going to come back and just do a window selection of the data that I want. Now the part that we're building here is, I'm going to build the one that's in a 64-pin QFP device. This particular package, this Cypress processor, comes in 3 different package styles, a TQFP64, an SOIC32, and a TQFP44 device. We're using this one. Now I could have selected completely across the table if I'd want to. I would have just had additional columns here. So this is the preview. And the goal is to, when you do an extraction, a window extraction in the PDF, have it appear in the preview kind of the way it's represented here, except in a tabular format. And the content here is what I need. So at this point, if I were to go back over to the assistant, it's telling me, okay, I've extracted data. I can now click the extract button. So if I click go, it's going to automatically extract this data. It's going to do the step of clicking this red button and populating that data into a spreadsheet. Now, if there was data that was not correct, I'll show you another PDF extraction where it's not a clearly defined table. So then I would just come back over here and I would do manual steps by clicking on that radio button, coming over here, and then clicking the other additional icons to modify this data to look correctly. So here I'm just going to say go. So what that did is that just migrated the data into a spreadsheet. And if I would go back to the Creation Assistant, it would then tell me information about the Scratchpad. So it's telling me that, okay, I have that Scratchpad information. I need to map the pin number column, the pin name column, and then I could just continue on and then finish out moving that to the final view. I'm just going to get out of here for right now. So what it was saying there is that I need to identify the column headers here. So this one happened to be the pin name column. I have a direction column direction being the pin type, input, output, bidirectional, etc., which I'll make the pin direction. There's a description column. I could keep this if I want to. I don't need it because I'm going to extract from the pin name, the direction, and this column here, the pin number. That's the only data I need to build a logical symbol, unless, like I said, you want to have some description. And some data sheets might not have a column called input, output, etc. And then you would use this column as your direction column, and we'll do a search on the contents of the text in here and try to establish what the pin type should be from something like, it says general I/O port. So if it's an I/O, we'll probably make it a bidirectional pin. So there is intelligence in that. In this case, I don't need it. Now you do see some data that's in red. When you have data that's in your data sheet that's overbarred, it's a negated pin name. So you may want to, when you go to OrCAD Capture, put overbars on your logic symbol, or you may just want to put a negated pin style, which is the little pin length with a bubble on it, on the graphics. So the fact that we recognize that overbar, we can now, in here, right-click on the screen and say I want to negate pins. And it'll find those highlighted red pins that had overbars in the datasheet, and I could append some nomenclature here, like _L for low or N for negated, or I could put the overbars in using the insert characters. So once I've done that, I am now ready to move to the final step of a table to build the graphical symbols. So I could do it from the menu pull down again. I prefer right-clicking on the screen. It's much easier than finding menu pull downs. And I just want to copy this data to the symbol view. So this is the symbol view. Let me just close this. This is the symbol view, and we have information that came from that previous table. But right now you don't see any placeholder for the graphics. And the reason is because it automatically went to a step of doing a validation of that data. So not necessarily is the information coming from the data sheet correct. So the software is going through algorithms to purge this data and give you some prompts and allowing you to either accept or modify that data to make it correct. So in this case, it's saying this on pin 1 or row 1, 2, 3, etc. The pin function isn't specified. So this had a pin name of clock 1. The pin function we could use, if we wanted to, the graphics of a little greater than or less than sign inside the body of the device, depending on which side it's on, to negate that pin or to represent that pin as being a clock pin. If you don't want to use it, you can just say accept empty pin function. If you want to accept that, you could say clock. A couple of these other here. So this one, the service L, it's all as being negated. So what I wanted to do here is I wanted to put a little bubble or balloon on the graphics for that pin type. So you see that I have different values that appear here. If I want to accept the software suggested value, I can click Apply Selected, and it will apply negative to row 3. If I say Apply All, it's going to apply all of the suggested values to all the pins, not the one that's highlighted. So for pin 1, it's not going to apply negative, it's going to apply clock. So it's going to apply the suggested value when I say apply all. And as users gain confidence in the suggestion, you'll end up just clicking apply all in most cases. It'll just walk you through the necessary steps to build a properly configured symbol. So in this case, the message here is invalid string in the pin direction. So the pin direction, again, you can think of as being a pin type. I/O built-in pull-up is not an acceptable OrCAD Capture symbol pin type. Software is suggesting that you call that bidirectional. So I'm going to, again, that's probably true for all of these. I'm going to say apply all and apply bidirectional to those pins. So this is a little bit interesting. The software is pin name and pin number count doesn't match. What that means is that you can see I have in the number column 3 pins, 14, 15, and 16. However, in the pin name column, I don't have 3 names that would match those 3 pins. I have a name that says IO8-IO1 space 0. So there's a space that came from the data sheet. So that wasn't 3 pin names. So what I can do is I can remove the spaces or put an underscore in it or remove the entire row. So I'm going to say go ahead and apply and go ahead and remove that space so that it will make 3 pin names to match the 3 pin numbers. And as soon as I do that, it expands all the bits for all the buses, since all the other ones had proper syntax, and we're now progressing on. And the next one is pin direction may be incorrect. The data sheet defined VDD and VSS as input pins. You could accept that if you want to, so you could say accept pin direction, or if you wanted to make VDD power and VSS ground, that's what the software is suggesting. Again, you could apply all if you wanted to do that. And then lastly, since it has multiple VDD pins and VSS pins, the software is saying that there's duplicate pin names, VDD. You could, if you want to, append an incrementing sequence number, like _1, _2, or you could append the pin number itself. That's useful on something like a BGA. Or you could accept the duplicate pin names. Now in OrCAD, years ago, duplicate pin names weren't allowed to netlist into Allegro or OrCAD PCB editor. Today, that's handled by the netlister automatically. So if you wanted to say accept duplicate pins, that's acceptable in OrCAD today. It's just that you'll get a warning message in OrCAD itself when you go to save a new symbol, let's say, that you were creating where you created multiple VDD pins. But it is acceptable because the netlister will handle it. What the netlister actually does is increment it by itself. It'll put an _1, _2, but it's in the netlist versus being on your graphical symbol. So I'm going to say accept duplicate pins. As soon as I do that, it tells me I have 64 pins with no errors or warnings. And if I click on the edit symbol graphics, it'll give me a placeholder to now start to build this symbol graphically. Notice that my appearance here changed going from my previous window to this window. And the reason for that is I'm past validation. I can no longer make a change to the data here. I can't type something new. I can't click on this direction column and tell it to populate with some other values because I've committed through validate. So if I wanted to change something, I just click the icon to go back to this yellow and white spreadsheet. And now if I wanted to change, let's say, a direction column, I can click on that or multiple fields, and I could right-click and say I want to fill that with some other value. The columns are context sensitive, so it knows what properties can go in a particular column. And you could just change it here by clicking on those. All right, so now we're ready to build a symbol, let's say. I could do it, as our slide presentation said, we could do it automatically or interactively. I'm going to start by just doing it automatically and show you what that process is. So I can right-click on the screen and I can say I want auto-assign by rules. The rules are very simple. Most companies have input pins going on the left, output pins on the right, bidirectional. Again, you can specify which side you want them to go on. Power pins, left, right, top, bottom, whatever side you want those pins. Or you could also say you want to assign the power and ground pins and any no-connect pins to a unique last section of the device, and it'll actually build as many gates as it needs, and then the last gate or gates it would put power and ground and no connect pins on. And if you're doing something like an FPGA, you could specify to build the part by banks. So the banks would have gotten populated doing the extraction probably from a text file, or it could have been from a spreadsheet. And you would have another column that would have been defined as banks. So you would have banks. We do have bank in here, but it's not populated with anything. But you could do it pin assignment by banks. Let's say you wanted to put maybe your bidirectionals on the left-hand side. So I'm just going to do that. And I'm going to say, go ahead and assign pins. So it automatically built the symbol based on those rules. Something about the rule set, as it gets populated into the graphics, this is currently using a template. The template style is OrCAD Capture. This is the default one that comes with the software. The rules themselves are defined under your settings, symbol style settings. I can't go there now because I'm in an active part to change it. But I do have the ability to change some other properties by just right-clicking and say Edit Symbol Properties. And if I needed to add some properties that weren't in my template, I could add them here, display them on the graphics, that type of thing. But as far as changing the appearance of this, I can't. So right now, if I turn on my grid and zoom in, and I'm just using my middle mouse wheel, scroll wheel, to zoom in or zoom out, and if I hold that middle mouse button down, I can just pan around. That was true when I was in the PDF as well. I can use my scroll wheel to zoom in, zoom out, and pan around. So right now my pins are 3 grids long, and that is, I guess that's a line pin style in OrCAD. It's 3 grid units. That's what my template was defined in. If I wanted it to be 2 or 1, I could have defined that in my template. So as you build templates, you can save the template to your own name. So here I have, a couple different names, and if I select one of these, let's see what my other symbol looks like. So now I have, in this example, I have pins. Oops, I'm changing that. In this example, I have only 1/10 long. We call them pin whiskers or pin lengths, and my pins are on 2/10 spacing. So this doesn't look very nice. I like the OrCAD one better. So you can change and create your own template styles and then apply those here. And what this is going to do is going to allow supervisors, managers to define a template style that your company is going to use consistently, so all the symbols basically look the same. This may not be the final appearance that I want this graphics to look like. Right now my pins here aren't centered. Maybe, and let's just take these pins and I'll drag and drop them to a new location. And notice that I had another pin there selected, pin 1, so I'm going to put that back over here. And then maybe I want to make the symbol a little bit more narrow, so I can select under the W icon here, the W text, into that field and say I want to make this component 6, I'll make it 14. So now it's more narrower. I don't know if that narrow, I guess, is a word. And I can also edit things like, let's say I want to put some separation here. I can drag and drop these pins to a new location. Maybe I want to put my VDD pins on and the VPP on the opposite side, so I'm just going to drag and drop those, move those over. Maybe I want to create some separation between my address bus and some of these other pins. So I'm just going to select the pins. Now you might not be able to see this in the graphics on the GoToMeeting. These pins are highlighted now. I drew a box around them by just holding my mouse button down and drawing a box. So I don't think you can see that when I do it. If I hold the Control key down on my keyboard and hit the down arrow key, it'll just move those pins down a grid at a time. So I've created some separation here between the address bus. Let's say an engineer wanted to have the most significant bit at the top of this list, I can select those pins, right-click, and say I want to swap selected. So now A15 is on the top, A0 is on the bottom. You can do that for the address bus as well if you want to do that, or the data bus. Again, if I want to put some separation in there, just move these down. Okay, so I did an automatic assignment. It grabbed all the pins that were in this table and populated them onto the graphics. How do I know if they're all placed? Well, right now my pin assignments up at the top here is saying all. It's displaying all the pins on this symbol. Well, actually all the pins on all the symbols, that there were multiple symbols. If I want to, I can pull this down and say I want to see only the unplaced pins. Well, there isn't any. They're all placed, and that is a requirement for you to be able to export this successfully into OrCAD Capture. If I had multiple symbols and I only wanted to see the pins that are on a particular symbol, I could say on this symbol. I can also make pins hidden or injected on a symbol. Maybe some of you out there don't use NC pins as graphical pins. You want to just make them an NC property. So you could do that by making them injected. So I've selected those pins, and maybe you can't see, but they're highlighted on my screen. I'm going to right-click, and I'm going to say unassign those pins. And watch what will happen. They go back over to the unplaced pin list. I mean, I could do that for anything. Let's say I took the CP bus, right-click, and say unassign. Now they're back over in the list. So that means my symbol's not complete. Having said that, I could create an NC property. I could select these pins, and I could make them injected. They're now hidden. So if I look at my hidden list, I'll see those pins. They don't appear in the unplaced any longer, and they're not on the symbol. That means that when I netlist this, or when I create an OrCAD logic symbol, they're going to have a NC equals whatever the pin numbers are. All right, and so now if I wanted to do something with this, let's just as an example here, let's say I wanted to put these on a separate key. So I could come up to my sections, create a new section, and I could just select these pins and say put them on the left side. Again, I could change my width if I wanted to make it something smaller. And I could just do that type of graphical maneuvering to get the part the way I want it to look like. Again, I have all my pins placed. If I wanted to select these, and you can do things like moving the pins around between symbols by just doing a move pins to a different section. So if I wanted to put them back on one, I could do that. Or I could just unpopulate them, go back to symbol 1, and drag and drop them if I wanted to. So that's the process. This symbol right now is validated. I'm ready to build a footprint for this. Maybe I want to export it to OrCAD first. Probably I wouldn't. I probably would build my footprint before I did that to make sure everything was correct. And let me just give you an example of that. And then we'll get into a different style of the symbol so you can see some additional functions and validations. Let's say I needed to build the footprint. Well, what footprint do I need to build for this particular package? Typically, the data sheets are defined where you have your pin table or your graphical information towards the top of the data sheet. I told you I would do another sample here of selection. So I want to save the symbol, let's say. So what I want to do back at the PDF, I'm just going to do a copy, and I'm just going to do a window selection around this data, go back to my symbol graphics, and say I want to do a file, save as, and I'm just going to paste that Cypress name in there, saving it to that library. My library is still empty, remember, in that Explorer folder. I'm going to say OK. I'll bring up the Explorer folder, and now, oh, I guess I did save it at one point, called Untitled. But this is the one I just saved, and so in that folder, it created the XML file for this OrCAD Library Builder environment data. So it's eSIM. I haven't created the footprint yet. It will go here if I want to in the same folder. So the footprint, as I was explaining here in the PDF, typically in your PDF, I'm just using the scroll wheel to scroll down. Graphical views are towards the top of the data sheets. Pin tables are, generally towards the top. But when you get down to things like the physical description, they're more at the bottom of the data sheets. And by using these bookmarks, you can select and go to the package diagrams. So here is the diagram for the 44-pin package. We need the 64-pin package. So I'll just scroll down in the data sheet. Here's the QFP64. The information here is package information. It's not a vendor-recommended land pattern. This is just dimensions for the physical device. And so we're going to use that information with the IPC algorithms to calculate what the footprint should be. So the critical information is the distance across the package, that's 16, millimeters, the 14 millimeters for the body. The pitch is 0.8. My pin width is 0.35. These all have tolerances, or most of them do. I'm not going to do that right now just to show you, or just to speed it up. The height of the device is overall 1.6, and my seating area for the package pin is 0.6. So going back over to the footprint, I'm going to say File, New, Footprint. And as I had mentioned, we have different calculators here. These are connectors. Now, connectors aren't IPC compliant parts, but we give them as a placeholder, as a template, so that you can use them to help expedite building those types of devices as well. In the surface mount here, we have just a bunch of different package templates that you can use. There's through-hole devices, and then there's some advanced dual-row QFN and some power type devices. So if I select surface mount QFP and load it, so here's the template or the calculator to build that part from the template. So you probably can't remember these dimensions, but I've done this enough times where I'm just going to start to populate these so we can get through this fairly quickly on the physical side. The template happens to be 64 pins. There's 8 pins on a side. Oh, excuse me, 16 pins on a side. I don't need the fiducials on this part, so I'm going to just click in the component tab here and say that my fiducials are false. I don't have fiducials on this part. So I could enter the dimensions here. So let's say I needed to change the pin pitch, and this is one I have to edit on the left-hand side here in the field. It was 0.8. But before I do that, I want to show you something else. Let me just come over here to change the dimensions. Again, I could change my L1 min and max. Currently the dimension is 12.9 nominally. But rather than edit fields here, it's much easier to just click on the dimension and change that value by just typing in the new value. I'm going to change it both in the X and the Y. I'm going to change my body to be 14, I believe it was. And now let's go back and expand the pin pitch to 0.8. The reason I did that is because had I expanded the pin pitch prior, I would have had violations because I had pins overlapping each other. So I generate that. You can see that now put 0.8 or put more distance between the pins. What you see in the little white rectangle, that's the package pin per the dimensions here or per the T and the W dimensions in the data field. I need to edit those to match the data sheet. Well, the package pin width was 0.35 plus or minus whatever it was, 15 or 5, I don't remember what the dimension was. You could change that right here, or you could put the min and the max by just changing your mode and type in the min and max. So that changed the pad size. If I needed to change, and I do, the seating area of that pin, that would be left to right here. I'm going to change that to 0.6. I have this component complete at this point. It's done. And what it's done to is IPC 7351 nominal settings. IPC has the nominal, maximum, and minimum. You can choose which one you want. That will affect how big the toe, heel, and side adjustments are and change the pad size. This is nominal. And like I said, I'm finished at this point. So what might I want to do now that I have the footprint completed? I want to export it, obviously. But like I said, when you're building a symbol and a footprint, one of the things that you want to do is you want to validate that this footprint matches your symbol. So if I click on Reports and I say compare the symbol to the footprint, no errors detected. So if I said footprint to symbol, okay, it says that pin number 65 was not found on the symbol. I have 64 pins on this symbol, if you recall, but I don't have 65. So that's a validation that I need to fix. I need to either get rid of pin 65 here as it highlighted it on the physical footprint, or I have to add pin 65 on the graphics. To add it here, I would just go back to the editable data, add pin 65 by putting in whatever it is, it's ground, probably a thermal ground. Or if I don't need the thermal pin per the data sheet, which I don't need, I can remove it from my physical package. To remove from here, I'm just going to click on the Component tab again, and I'm just going to say that we don't have any size to the thermal pad. And now again, if I check that, I now have no errors in both directions. So that's one of the reasons that you want to build the logic symbol. And before you even export it, check it to the physical device that you're building. So now I have a complete set. I can do a file save here. I could save, let's do a file, well, let me do a file save. And I'll show you another feature of this. So currently, it's telling me that my footprint name is that, well, that string right there. IPC naming conventions, QFP 80 pitch, 16 across the package in the X and the Y, with a height of 120, 64 pins. Well, that's not correct. Let me cancel this. If you recall, the height of the device was 1.6. So I'm going to change this to be 1.6. Now watch what happens when I do a file save again. Let's do a file save as so you can see it. Oh, come on. Oh, that's interesting. Try it there. All right, it's not going to do that. All right, anyway, it would have put 160 as the last digits for the height of that. Not sure why I'm not seeing that. All right, so let's go back to the symbol and export it. File. Oh, I see what happened. I think I got rid of my pins in that view. So let's do a file export to OrCAD. So if you recall, we moved pins from section 2. We don't want that anymore. I'll just say yes. I'm going to save it. I'm going to export it. And I'm going to invoke Capture. So there's the symbol that I just created. Likewise, if I do the footprint, and you could edit that some additional way if you needed to once it's in OrCAD Capture. You're obviously aware of that. Let's go back over to the footprint. Let's try this one more time. File save as. So now you can see that my name is 160 here. That's the height. I want to export this, so I'm going to say File, Export. And there's my footprint. That's interesting. Not so sure why that closed so quickly. My footprint was there. It's like I did something with my mouse to make it disappear, exit before. All right, so here's the package. If I wanted to look at the 3D view, since I didn't generate a step model, I don't think. There was a step model there, but it might not be the correct one, so I'm not even going to open that one up. I forgot to click the Generate button when I was in that side view to show you the step model. The way I would have had to do that is in the side view, just say Generate Step Model. Okay, that's all it takes to generate the step model. And now if I would export this again, I could show you the 3D footprint for that part. All right, let's just, as we get shorter on time, I want to show you another example of a data sheet that's not so clearly defined. So I'm going to say File, New. Oh, one other thing about this environment now, if I go back over to my library, or if I wanted to just get out of here into a new part, the fact that I saved both my logic symbol and my footprint, and I was referencing a PDF data sheet, all that data is resident when I open up that part again. So if I said File, Open Part, and I go to a project directory, now I don't have the I don't have my added here of the library. There it is. If I opened, well, I don't have that one saved as Untitled, but if I opened up one that was saved before, it's currently open. But if I would open it up, I would get the footprint, the graphical symbol, and the PDF all linked together in the same environment. It gets saved that way. It knows what it used. So in this case, I'm just going to say File, New, Symbol from a PDF. Again, I'll put it here in Library. I'm just going to save it to Untitled. So this data sheet, I would browse through to my table of information or the graphical view. So here's the table information. Now in this case, it's not a clearly defined table, meaning that it doesn't have the separator lines horizontally between the rows. So if I wanted to do my extraction, I can click on Select Area, or I could go back to the Symbol Assistant. It's a table, but it's not necessarily clearly defined. But when I draw my box around the data here, notice what happened. I didn't get a nicely defined preview. And the reason is because it doesn't have those separator lines, so this all run together into one string. I can fix that by saying, okay, there is 24 rows, and I could put 24 in here. But when I go to the next page of the data sheet, it's going to start at 25 and go to some other number. Now I got to do a little bit of a math and determine whether how many pins that is. Do I add a pin, subtract a pin? Is it the exact whatever? So you more conveniently could just select on space between, and we're going to automatically put separator lines based on 40 pixel units. And you can see that 40 pixel units is probably too great because I'm getting spaces in here in my data sheet. But it did separate the content. So now what I can do is I don't have to rerun it again and say, okay, now try 60 or 30 or whatever the number might be. Just click Optimize. And Optimize will automatically adjust, which you can't see right now. There's blue lines that display horizontally between these rows. It doesn't display over the web demo. But it separated that data to what I want it to be. And so what I can do, and I have to do at this point since I didn't specify any columns, I need to come over to my toolbar set and click on the one that says Manually Divide Columns. And what that means is I'm going to click someplace and it's going to put a separator line between the pin number and the pin name. And as soon as I click there, it separated that data. If I click right here, it now separated the pin name from the direction column. This now looks like what I need it to look like to continue to the next step, and I'm going to say Extract. I'm going to go to the next page of the data sheet, and I'm just going to put the data around that. Again, it's the same situation. It's all one row. So I'm going to say, go ahead and put space between, Generate, and it's putting those blue lines in right now, which you can't see. Optimize. I see I still have some run over here of text. Optimize again. And I think if I scroll down, okay, I have just basically one row of data for each pin number. That's good. I still have to put the separator between columns. I'm now done. I'll extract. And so now I can go to my scratch pad and just quickly do this. I'm going to identify this as the pin number. This is the pin name. This one has the direction. So I have that data there. It's going to validate. The validation is going to go through a set of sequence of data that is going to be validated to make sure it goes to capture successfully. So I have a 0 is not a valid pin number. Allegro can't have a 0 pin. So I'm going to change the value and make it some other number. I'll make it 65 because I know that there are 64 pins on this device. Apply that. Invalid string in the direction. This is the type of pin. Miscellaneous digital is not acceptable. Software suggesting input. If we needed some other value there, we could select it from here. Maybe some of these are different, but again, the software, as you gain confidence, will be picking in most cases what you need. So you can just say apply all. Pin numbers. There's no number assigned. Oh, I did have one row of data that wasn't acceptable. So I'm going to remove that row. And then pin functions, again, that's the clock pin. Or I don't know if you noticed that. I forgot to point it out to you. And we have duplicate pins. I'll accept duplicate pin numbers. When we did the graphics on the other one, because we had negated pins and clock pins, it put the correct pin type on those pins. So just one thing I could do looking through this, I do have some pins that are unassigned. So I'm just going to sort this data. Actually, let's do it back in the other view. I'm going to sort this data by pin direction. And you'll notice now we have some unassigned. That would be okay, but you might want to change them to their correct values. So I would probably reference the PDF and look at certain things here, like AP is an audio output. So here I'm going to click on these, right click and say I want to populate those with input, but I want audio output or audio to be an output, and I want SD to be a bidirectional pin. Passed validation, okay. And now I'm going to assign by rules. I could specify that I want it to have so many pins on a side. Maybe I want 70 pins or 80 pins maximum on a side of the device. I don't know how many pins there are on one side here, so I'm just going to pump that up and just say assign. So there's my symbol, and again, you would just edit the graphics on this to match your device by moving pins around or moving in between gates on your symbol, etc. For example, I might want to just grab the VDD and the power pins here and move them to the other side. Maybe I want to create some separation between some of this other information. So let's see. So I'm just drawing a box around 2 pins at the top of that list and moving the rest of the pins down just to create some separation. So that's how you can just move pins around, etc. All right, and let me just show you one more example. I know we're at the top of the hour here, but here's another way that you can use the symbol tool and the footprint tool. I'm going to do a file, open, part. This one has the symbol already built, I think. Let's see, which one is it? I think it's this one. And let me see if I still have my previous footprint there. Let me do file close. Okay, so here's my symbol. I need to build a footprint for this. If I looked at the data sheet, and I think the data sheet is here, it's a BGA, and the BGA happens to look like this. Whoop. Looks like this, where there are certain pins that are grayed out that are reserved pins, and then it also has other pins that are not populated. How would I build this? In Allegro, I'd have to place a bunch of pins and figure out where they are, etc. Here's how you can use the symbol tool and the footprint tool to guide you through that process. So if I go back to the footprint tool and say that I need to build a new footprint that is a BGA, here's the template. The template has a matrix field of pins 11 by 11. This particular part was 12 by 12, so I would just type in the number of pins in the rows and columns. So now what I can do, since I already have my symbol built, and that particular symbol, I don't know how many pins it has, 100, well, 12 by 12, 112 pins, in this one because there's pins that aren't populated on the logic when I built the logic symbol for this. So what I can do now is I can come back here and say I want to annotate the symbol to the footprint. In this example, I'm just going to do the pin name. But if you were doing something like an FPGA, you could do banks, you could do the power, you could highlight pins on the device. I'll specify direction as well. So I'm going to annotate that information that came from the logic symbol onto my footprint and say annotate. Now what I want to do is I just want to do a graphical display of pins that are missing pin assignments. So if I say display, it will highlight those pins that are missing on coming from the logic symbol to the footprint. And I don't know, I'll do this part, then maybe I'll come back and show you the other. So that's done. And now what I want to do is I just want to make those not populated. So there's my device. And now I would do a file export. Now there is one error here. There's a pin missing. And the reason for that is because the data sheet didn't account for one of these other pins down in the pin table section. It didn't account for that pin. It was missing in the data sheet. And this is another verification that you can use to, and we often do find errors in the data sheets themselves by just doing this type of thing. So if I wanted to make that populated at that point, I would just go back and put it back in. So now there's my symbol correctly. So that's just an example of using the logic symbol to the footprint for verification and then outputting to their environments. I hope I covered everything. Again, if you have questions, please make sure you type them in the question box on your screen. I'll follow up in emails to answer any of your questions. I don't believe I still have my PowerPoint presentation open to give you the contact information. Again, my name is Ron Smith, and my email address is ron.s@ema-eda.com. Thank you for having joined us for this training tutorial. Hopefully you'll be able to use the software as part of your purchase of the OrCAD Capture promo, where you get this tool free for, I forget how many days, 90 days or something like that. Or if you've purchased the tool, if you have any questions as you're going through it, please post to tech support or send me an email. Thanks again. Have a great day, guys. Bye.